Hello everyone, welcome to the first lecture in sequence and series. In today's lecture, we'll try to understand what is sequence and what is series. We'll try to see how many types of sequences are there and what is progression, and in progression, we'll try to understand what is arithmetic progression. So let's start the lecture with sequence. A sequence is nothing but writing numbers in some specific order. Example, 2, 5, 10, 17, 26, so on. This is one example of sequence. Just write the numbers in some specific order. One more, 1, 1, 2, 3, 5. This is one more example of sequence. So if you observe in the sequence, there are numbers, okay, which we are writing in some order. These numbers are called terms. These numbers, 2 is the first term of this sequence, 5 is the second term of the sequence, 10 is the third term of the sequence, 17 fourth term, 26 fifth term. Okay, the numbers which are there in the sequence will call them as terms. In general, terms in sequence will be denoted as T1, means T1 or A1. This is first term, T2, A2, second term, T3, A3, third term, so on, Tn, An, which is nth term, Tn plus 1, An plus 1, which is n plus 1th term. If you take this example, T1 or A1 is nothing but 2. This is the first term. T2, A2 is 5. T3, A3 is 10. T4 is 17. T5 is 26, so on. Let's see types of sequences. Types of sequence. First, finite sequence. Finite sequence. So in word itself you are finding finite. If a sequence contains finite number of terms, if sequence contains finite number of terms, such type of sequence is called finite sequence. Example, 2, 5, 10, 17, 26. See, in the sequence we are able to see there are 5 terms and we are able to say 26 is the last term. Okay, so when in a sequence there are finite number of terms, such type of sequence is called finite sequence. Second, infinite sequence. Infinite sequence. If sequence contains infinite number of terms, if sequence contains infinite number of terms, such type of sequence is called infinite sequence. Example, 1, 1, 2, 3, 5, 8, 13, so on. See, when we keep dot at the end of the sequence, it means the terms in the sequences are the terms in the sequence is tending towards infinite. That means in this there are infinite number of terms, and clearly we are unable to say what is the last term in the sequence. See, in the first example, if I ask you what is the last term in the sequence, you will say, right, 26 is the last term in the sequence. And if you go to this, if I ask you what is the last term in the sequence, what do you say? We don't know. Okay, so dot 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 represents what? The terms in the sequence are tending towards infinite. Infinite number of terms are there in this sequence. So these are the two types of sequence. One is finite sequence where you know exact number of terms. Next is infinite sequence where we don't know number of terms in the sequence. Means we don't know, means the meaning is there are infinite number of terms are there. Let's try to understand what is series. Series is an expression on adding or subtracting the terms of the sequence. We have learned, right, what is meant by a sequence. Okay, so in between terms of the sequence, if you put plus or if you put minus, okay, whatever expression we are getting, such type of expression is called series. Example, 2 plus 5 plus 10 plus 17 plus 26. This is one series because 2, 5, 10, 17, 26 is one sequence. So what we are doing, we are adding the terms in the sequence. So this is called series. Example number 1. Example number 2. 1 plus 1 plus 2 plus 3 plus 5 plus 8 plus so on. We are adding again a terms of a sequence. Third, 1 square minus 2 square plus 3 square minus 4 square plus 5 square minus 6 square plus so on. See, we are adding and we are subtracting. Okay, so this is one type of series. Okay, series is nothing but adding terms or subtracting terms of a sequence will give you an expression. Such type of expression is called series. So now we understood what is sequence and what is series. Now let's go to the next progression. Progression is nothing but a sequence. See, actually sequence contains patterns. Sequence may not contain patterns. Okay, but sequence with patterns are called progressions. Sequences with patterns are called progressions. That means, for example, if you take 2, 5, 10, 17, 26, so on. Now, if you observe, there is a pattern in this sequence. I'll tell you what is that pattern. You just pause the video and try to understand what is the pattern you are finding in this progression or in this sequence. Because there is a pattern in the sequence, I'm calling it as a progression, right? So just pause the video and try to see what is the pattern you are finding in it. See, if you add 3 to the first term, you are getting the second term. And if you are adding 5 to the second term, you are getting third. And if you are adding 7 to the third term, you are getting fourth. If you are adding 9 to the fourth term, you are getting fifth. Suppose if I ask you what is the next term, what you will do? We'll add plus 11. So if you add 11 to this 26, which is 37, will be the next term in the sequence. Since the sequence is following some pattern, this is called progression. Example number 2. 3, 9, 27, 81, 243, so on. See, if you observe, there is again a pattern in the sequence. If I multiply 3 to the first term, I am getting second term. If I am adding 3 to this, I am getting third term. If I am adding 3 to this, I am getting fourth term. If I am adding 3 to this, I am getting the fifth term. If I ask you what is the next term, what you will do? Will multiply 3 to this. So 243 into 3, 729. 729 is our next term in this sequence. Since this sequence is having some pattern, the pattern is what? If you want a term, any term, you just need to multiply 3 with the before term. So since it is having some pattern, this sequence is called progression. 1, 1, 2, 3, 5, 8, so on. If you observe, there is again a pattern in this sequence. If you want third term, you are adding these two terms. If you are adding fourth term, you are adding these two terms. If you want to get this, you are adding these two terms. That means if you want the term, you just need to add before two terms. Okay, suppose if I ask you what is the next term in this sequence, what you will do? You will add these two. 5 plus 8. 5 plus 8 is 13. So 13 is the next term in example number 3. Since there is a pattern in this sequence became arithmetic progression is a sequence whose terms increase or decrease by a fixed number. Okay, so let's take one example. We can understand in a better way if we take one example. For example, 7, 11, 15, 19, so on. If you observe this sequence, every term is increasing by a fixed number. See, if I add 4 to the first term, I am getting the second term. If I add 4 to the second term, I am getting third. If I am adding 4 to the second term, means third term, I am getting fourth term. That means every term is increasing by a fixed number. Okay, so this type of sequence where there is a pattern in it, we'll call it as a arithmetic progression. Okay, so whatever this fixed number is there, right, where the terms are getting increased, so this fixed number is called common difference of this arithmetic progression. So this fixed number can be positive, that fixed number can be negative, that fixed number can be zero also. For example, if I write one more example, 7, 3, minus 1, minus 5. See, if you are going from 7 to 3, you are subtracting 4. From here to here, again you are subtracting 4. Here to here, again you are subtracting 4. That means in this is also arithmetic progression because terms are decreased by a fixed number here. Okay, so in this, the common difference is what? Minus 4. And that common difference can be 0 also. This is also an arithmetic progression. 7, 7, 7, 7. See, 0, 0, 0. Okay, so in this, the fixed number became 0. So this is also an arithmetic progression. So what is meant by arithmetic progression? Arithmetic progression is a sequence where terms increase or decrease by a fixed number. The fixed number is called common difference. Okay, this common difference will be represented as small d, guys. Okay, so here in this sequence, this small d is equal to how much? 4. In this progression or sequence, common difference is equal to minus 4. In this, common difference is equal to 0. Okay, so I hope now you understand what is meant by a arithmetic progression. Okay, so let's write general arithmetic progression. What is its nth term? Okay, if a is the first term and d is the common difference, then arithmetic progression can be written as this. This is the general arithmetic progression. If a is the first term, if you want second term, what you need to do? You need to add d to the first term. So this will become a plus d. Again, if you want third term, again add d to the second term, a plus 2d. Again add to the third term d, a plus 3d. So a plus 4d. So on. This is general arithmetic progression. Okay. T1 is what? T1 or A1 is A. T2 or A2 is A plus D. T3, A3, A plus 2D. T4, A4, A plus 3D. So on. What is Tn? Pause the video and think what is Tn. If you see there is a pattern in this, try to pause the video and think what is Tn. Okay, now see, T1 is A, second term is A plus D, third term is A plus 2D, for 3 A plus 2D, for 4 A plus 3D. That means whichever term we are talking here, one less D is coming. That means nth term is what? A plus 1 less of this D, n minus 1 into D. So Tn, which is also called as general term of AP. General term of AP is A plus n minus 1 into D. A plus n minus 1 into D. And the second thing is, what is T2 minus T1? If you subtract second term from the first term, okay, if you are subtracting T2 minus T1, that means you are subtracting first term from the second term. So how much? A plus D minus A, D. T3 minus T2. From third term you are subtracting second term, again D. Fourth term to third term, again D. That means if you subtract any two consecutive terms, okay, T4 minus T3, T10 minus T9, Tn minus Tn minus 1, so that will give you always common difference D. So Tn minus 1 will be always D. Tn minus 1 will be always equal to D. Okay. So we'll solve problems after completing the sum of n terms. Okay. So let's try to understand how to calculate sum of n terms of AP. So we know AP terms are what? A plus D, A plus 2D, A plus 3D, so on. What is the nth term in this? A plus n minus 1 into D. So Sn represents sum of n terms. We can write here Sn. Sum of n terms of AP. That is nothing but A plus D plus A plus 2D plus A plus 3D plus so on up to A plus n minus 1 into D. So what I am doing is, again I am taking same Sn, but I am writing from back. See, if you add in this direction or if you add in this direction, result won't change, right? So this is what? A plus n minus 1 into D. Last term. A plus last but one term is what? A plus n minus 2 into D. Last third term from the last is what? A plus n minus 3 into D. So on. A. What I have done? First Sn, A plus D plus. So you can keep here brackets so that you don't get confused. Okay, so this is Sn where we are adding all the terms. Same Sn, but I have written from back. Now I am adding these Sn. Sn plus Sn, 2Sn. Now add these two terms, A, 2A. Here n minus 1 into D. I am adding these two. Next, I am adding these two. A, 2A. Here 1D, here n minus 2Ds. N minus 2Ds are there, we are adding 1D. So what happens? N minus 1D. Now I am adding these two. A, again A plus A, 2A. 2D we are adding with n minus 3D. This is n minus 1D, right? Here we are having n minus 3Ds are there. We are adding 2Ds, so it will become n minus 1D. And if you observe, every time we are getting 2A plus n minus 1 into D, 2A plus n minus 1 into D, 2A plus n minus 1 into D. Okay, So here also if you see last a plus a, 2a plus n minus 1 into d. So totally how many 2a plus n minus 1 d's are there? How many terms are there? That many 2a plus n minus 1 d's are there. So here we are calculating sum of n terms, right? So totally how many 2a plus n minus 1 into d's will come? It will be n into 2a plus n minus 1 into d. This is 2Sn. So Sn is equal to how much? N by 2 into 2a plus n minus 1 into d. So this is Sn, sum of n terms of AP. Sum of n terms of AP is what? N by 2 into 2a plus n minus 1 into d. Where n is, here n is what? N is number of terms which we are adding. A is first term of your AP. D is common difference of your AP. Okay, and this result can be written in other way also. See, I'm just modifying the result. Sn is n by 2 into this 2a is there, right? I am writing as a plus n minus 1 into d. Okay, this 2a is there, right? This 2a I am writing as a plus n minus 1 into d. So that means this is n by 2 into a plus, this is we already know. What is this, guys? A plus n minus 1 into d. Check. A plus n minus 1 into d is Tn. So this is also called as last term. Okay, L. We'll write it as L. So here we can replace this with Tn, or since I can write it with En also. Okay, so n by 2 into A plus, I told you the nth term can also be written as last term L. So L. That means if you know last term, first term, number of terms, in that scenario also you can use this result to get sum of n terms of AP. Okay, so I hope there is a clarity on how we have achieved the result Sn of an AP. So please go through it once. I hope you understand. If you have any doubt, please go back to the video and try to understand it. Okay. So let's try to solve few problems. First problem number 1. Find the 10th term of AP 2, 7, 12. So first, we'll try to understand what is the first term, what is the common difference, and all these things. Okay, so 2, 7, 12. So clearly this is the first term. First term is 2. Common difference. If you want common difference, what you'll do? You can subtract T2 minus T1. Okay, second term minus first term will give you common difference, or third term minus second term will give you common difference. That means T2 minus T1, which is 5, is the common difference for this AP. Now they are asking what? 10th term. That means they are asking T10. T10 they are asking. So we already know Tn. Tn is what? A plus n minus 1 into d. Now T10 they are asking. T10 is A plus 10 minus 1, which is 90. So A you already know 2 plus 9 times of D we already know 5. So 2 plus 45, which is 47. So 10th term in this AP is 47. 10th term in the given AP 2, 7, 12 so on is 47. So very simple chapter. You just need to see what they have given in the question and what is your required. Okay, you require T10. T10 means the only unknowns are A and D. Anyway, if they gave you sequence, you can calculate A and D, right? Okay, so let's go to the second question. See, if you want to solve, try to pause the video. Okay, try solve on your own. Okay, once you have done, you can come back to the video and you can check the solution. Which term of the AP 21, 18, 15 is minus 81? Also, is any term 0? Okay, so they are asking us here which term in this AP is minus 81. So let's try to write first what they have given. A is equal to 21, common difference is equal to minus 3. 21 means 18 minus 21, right? T2 minus T1 will give you the common difference. So they are asking which term is minus 81. Let us consider that as Tn. Okay, Tn means what? A plus n minus 1 into D is minus 81. So A we know 21, n minus 1 into D we know minus 3 is equal to minus 81. So n minus 1 into minus 3 is equal to, let's take minus 81. This 21 comes this side, minus 21. So n minus 1 into minus 3 is equal to minus 102. Okay, so minus minus will get cancelled. 3 table, 3, 4, 34 times. So n minus 1 is equal to 34, n is equal to 35. That means 35th term in this sequence or in this progression, in this arithmetic progression is minus 81. Okay. Also they are asking any term 0. So let's calculate. Again we'll equate Tn to 0. Okay, Tn to 0. That means A plus n minus 1 into D equal to 0. A is how much? 21 plus n minus 1 into minus 3 equal to 0. So n minus 1 into minus 3 is equal to minus 21. Minus minus will get cancelled. N minus 1 is here how much? 21 by 3. N minus 1 is equal to 7. N is equal to 8. So 8th term in the progression is 0. Yes, we can say 0 is the term in the given arithmetic progression.